Hi, welcome to the video on Introduction to Clustering. By the end of this video, you will be able to describe clustering, explain properties of the cluster, list industry applications of clustering. In this module, we will begin with recalling the difference between supervised and unsupervised learning. We will quickly review the two types of supervised learning, that is classification and regression, and we will then go deeper to clustering, that is a type of unsupervised learning. So, let's quickly review what we have covered in supervised learning in this training. We looked at a regression problem where the task was to predict the sale price of the houses. We also looked at classification problems where we identified whether a bank customer will churn in the following month or not. So, if you look at both these cases, we had a target variable, sale price in case of regression problem and churn in the classification problem. Such problems where we have a fixed target to achieve are known as supervised learning problems. We trained our model using both the independent and the dependent variables, which are represented as x and y respectively in this case. But clustering, on the other hand, is an unsupervised algorithm in which we do not have a defined target or independent variable, and we try to find patterns in the observations based on their features. Based on the pattern, we divide the entire dataset in groups. These groups are called clusters. Let's understand it more clearly using a business example. Let's say a bank wants to segment its customers. The bank knows the income of their customers, their occupation, gender, the amount of debt, etc. etc. Using these attributes, the bank wants us to segment its customers into meaningful groups. Now, for the sake of simplicity, if we consider only two features, that is income and depth, and plot these two features against each other to segment them. Consider this plot. On the x-axis, we have the income of the customer, and on the y-axis, we have the amount of debt of the customer. Here, you can clearly visualize that these customers can be segmented into four different clusters. Black cluster represents low income and high debt segment. Red cluster represents the high income and high debt segment. Green cluster represents the low income and low debt segment. Blue cluster represents the high income and low debt segment. This is how clustering helps to create clusters from the data. Banks can further use these clusters to make strategies or introduce some new schemes depending upon the clusters. Now, we know what is clustering and how clusters are helpful. Let's look at the properties of these clusters. The first property is that all the data points in a cluster should be similar to each other. Let's take the customer segmentation example here. If the customers in a particular cluster are not similar to each other, then their requirements might vary. Let's say if the bank gives them the same offer, some of them might not like it and their interest in the bank might reduce, which is not what we want, right? So, all the data points within the same cluster should be similar to each other so that the same strategies can be applied to them. The second property of clusters is that the data points from different clusters should be as different as possible. To understand this, let's go back to our customer segmentation example. Which of these cases do you think will give us the better clusters? If you look at case 1, the black and green clusters are very close to each other, and hence the properties of the customers in these two segments are very similar to each other. Similarly, the clusters red and blue are also very close to each other and hence share very similar properties. Whereas if you look at case 2, points in the red cluster are completely different from the customers in the blue cluster, as all the customers in red cluster have high income and high depth, and customers in blue cluster have high income and low depth value. So, clearly in case 2, we have better clustering of customers. Hence, data points from different clusters should be as different from each other as possible to have more meaningful clusters. So these are the properties which a cluster should follow. Now the concept of clustering can be used in various scenarios. Let's look at a few of its applications such as customer segmentation, document clustering, image segmentation, recommendation engines. Clustering is generally used for segmenting customers. As we have already seen in the previous example where the bank wanted to segment its customers. Now let's say you have multiple documents. You can use clustering techniques to cluster these documents such that similar documents are in the same clusters. So this is also an interesting application of clustering. We can also use clustering to perform image segmentation. In image segmentation, we try to club similar pixels in the image together. Clustering can also be used in recommendation engines. Let's say you want to recommend songs to someone. You can look at the songs liked by that person and then use clustering to find similar songs and finally recommend most similar songs. These are some of the applications of clustering. There are many more applications which you can think of. Now, we know that the aim of clustering is to make meaningful groups of data. As a result, we have to have some evaluation metrics which ensures that the clusters formed are meaningful and efficient. In the next video, we will discuss those evaluation metrics. See you there.